Good morning to you all. Am I audible to you? Okay, so please give your attendance over here by this time, because in the first 5 minutes we are going to take the attendance only. First 5 minutes attendance will be considered. Okay, so all of you have submitted the assignment that I have given. Please write 1 if you have submitted assignment. Please write 0 if you have not submitted the assignment. So Kaushik, Girija, Shahnawaz, Rupam, Devarshi, Pranav, Vedanto have submitted. Okay. Chandan, Ankur, Abhilasha, Mihin, Arindam, Ayush, Surjo, Himjyoti. Okay. So most of you have submitted. Okay, fine. Very good. Because as it is an online classes are going on, so it in the classes or the most of the classes we are going to give you assignments so that you can be up to date, and it should be an interactive one. Divan, please mute yourself. Okay, so the what we are discussing in the last classes, I'm coming back to the same position that to make an device or IoT means what? That connecting each and everything with the internet, right? It may be your chair also. Now, if your chair, if you want to make it as an IoT device, that case, what you have to do? Uh, you have to tag, first of all you have to tag this device with an IP address, right? So if you tag the device with an IP address, that means it is connected with the internet. Now this is connecting a device with the internet is not the only solution. We have to put some sensors on the chair so that if suppose I want to make this IoT device such like that, if somebody sits into the chair, that immediately it will be sensed. So for that we have to what we have to do, we have to put one pressure sensor within this chair. So if we put a pressure sensors, and if somebody sits in the chair, then immediately one pressure will generate, and that generated pressure through IP address it will go to the internet, and you come to know that somebody has sits into the chair. Now the thing is that the sensor, the pressure sensor has sensed it. Now who is going to send that pressure data to the internet? So there is some controller or computer is required. Now through controller also you can send it, or through computer also you can send it. Now if we put a controller, microcontroller like Arduino, or if you put a Raspberry Pi over there, and what the Raspberry Pi will do, that in the Raspberry Pi you might have seen that there are 40 pins are available. Can you see that in the within the Raspberry Pi there are 40 pins are available? So what are the basic job of those 40 pins? So the basic job of those 40 pins are they are the input out the general input output pins. So you can see here these 40 pins. So these are the general input output pins through which you can connect at least 20 sensor device with that Raspberry Pi. Now, if I put one pressure sensor into my chair, that pressure sensor will require 2 pins out of these 40 pins to be connected with the Raspberry Pi. So I have connected it with the Raspberry Pi. My first job is done. Now, what should be my next job? That if a pressure generates, that case immediately that data will be acquired by this Raspberry Pi, and it will be sent to the internet through the IP address. So this is my function. Now, what we are getting out of this, that one sensing device is required. So one sensing device is required, who is sensing this one, and it will send it to the Raspberry Pi and it is, or any other microcontroller, and after that it is going to the internet. Now, so only sensing, do you want as a system should be based on only sensing only? So if means that what would be the real-time applications, that if somebody sits into this chair, until and unless if I can control that chair, means I want to control that whom I should permit to sit into this chair or whom I should not permit to sit into this chair. So that case, what I have to do, I have to put one barrier in front of the chair, and that barrier will be controlled by the user. Means that if I open that barrier, somebody can sit into the chair. If I close that barrier, then somebody will not be able to sit into the chair. Now, if I have to make it automatic, that case I have to put one actuator into the chair. What the job of the actuator? Job of the actuator is to, it will take the electrical signal, it will take the command from the Raspberry Pi or from the microcontroller, and after that, based on the command, it will work, and it will convert this electrical signal to mechanical signal, or it will convert your command to a mechanical signal or mechanical output. So, first of all, we are sensing this one, whether somebody is trying to sit into this chair or not, and after that, we are putting some actuator to control within this chair, and with this sensor, actuator, and microcontroller, these three combinations are actually making my entire Internet of Things. So your Internet of Things means you need one sensor. You have to remember these things, where you need one sensor, one actuator, and one controller. Is this okay? Or any question? Is this okay with you? Please write one if it is okay with you. Or if you have any question, you can ask me. Now I am going to the prime concept of Raspberry Pi IoT, is that concept of sensors and actuator. What is sensors and what is actuator? A sensor detects the changes in the ambient conditions or in the state of another device or a system, and forward or processes this information in certain manner. Means we are human, we have 6 sensors, right? Our eyes, our nose, ears, so our skin. So we have various sensing organs are there, through which we are sensing the ambient condition of the environmental phenomena. Okay, and based on this, we have our controller, which is in our brain, and which is give us the signal that what to do, and we are taking our decision through our controller, and we are doing through our output devices like our hand, our leg, or our mouth, or whatever it may be. So the same way the human body works, the IoT sensor, IoT based sensing devices also works. So they are sensing the ambient conditions of the environment, and based on this, they are putting it into the microcontroller, and actuator does the physical changes. Okay. Now they perform some input functions by sensing or feeling the physical changes in the characteristics of the systems in response to stimuli. Stimuli means if any stimulating or provocating phenomenon comes. If somebody asks you something, so that is a stimulus. Or in case of sensors also, if somebody sits into the pressure sensor, that case pressure becomes a stimuli. Or in case of gas sensor, if the gas comes out of the environment, that gas is the stimuli. Like here, what is written, pressure or temperature is converted to electrical signal in case of the pressure or the temperature sensor. Now, there are three concepts, and people sometimes most make an misconception that what is the difference between sensors, actuator, and transducer. Now, already I told that sensor is sensing the ambient condition of the physical phenomenon, and what is actuator? Actuator is converting an energy into motion or mechanical energy. So here you can see that from the environment itself, we are getting the ambient conditions through the sensors putting it into the controller. Here my controller is my IoT device, my microcontroller, Arduino, or my Raspberry Pi. And we are putting it to the actuator, which is converting this energy or the electrical signals or the whatever the command given by the controller to the motion or the mechanical energy. So this is the basic concept. Now, in between them, what is transducer? Okay, before that, I need to tell you what are the different kinds of actuator in IoT, Internet of Things. So there are few of the popular actuators. There are so many actuators are available. In case of robot, humanoid robot, also there are more than thousands of actuators are available. So I am not going into details of those actuators. We are discussing only the few of the actuators that we basically use in our IoTs. But later on, I will discuss about the humanoid robot actuators also. Like the electrical motors. So in case of electrical motors also, three kinds of electrical motors are there. DC servo motors, AC motors, and stepper motors. I will discuss each of these motors one by one later on. Solenoid. Solenoid is also one popular actuator. What is the main job of solenoid? Solenoid is basically a spiral of your wire through which if you pass any magnetic field, or if you enter a magnet inside this copper core copper solenoid, then immediately that magnetic energy will be converted to electrical energy. And with the same concept, actually your fan also works. So if you enter these magnets into that copper wire, that one magnetic field will be generated. That magnetic field will be converted to electrical energy, and through this electrical energy, you can move a fan. Some hydraulic actuator. Use of hydraulic fluid to amplify the controlled command signal. So that also I will show you in the valve, or in case of broiler, they use this type of hydraulic actuators. Then pneumatic actuators. So where you use the compressed air as the driving force. So if a compressed air comes, it sends the force, and based on this force, so it starts working. So these are some few of the popular actuators. Now, so now the difference between the sensors, transducers, and actuators. Now, what is transducer? Transducer is any device which converts one form of energy into another, like your electrical energy to mechanical energy, your sound energy to mechanical energy, or your pressure energy to mechanical energy. So these are the different forms of actuator. One simple example I am giving, like here, whatever I am telling in this class, and you are hearing it as a voice, right? How the entire process goes on, because I am telling and my speaker in my laptop is taking the entire signals, right? How it is taking the signals, because whatever I am telling, it is coming as a frequency, right? Now whatever I am telling, it is coming as a frequency. You can see that in front of the microphone there is a diaphragm is there. Now have you seen the diaphragm? Now what the diaphragm is doing, that whatever somebody is telling or singing or whatever it may be, so the diaphragm starts vibrating, because whatever you are saying, that is basically a frequency. Based on the frequency, it is vibrating. Now that vibration frequency is converted to an electrical signal, and that electrical signal is being converted to a speech signal. So this is a form of an actuator, sorry, transducer. Even actuators also is doing the same thing. That is, it is taking the electrical signal to mechanical energy, electrical to mechanical, or some command that we are giving in terms of an electrical signals itself, that is also converted to mechanical energy. I am giving another example of a solar cell. How the solar cell works. In case of solar cell, the lights incident into the solar cell, and that light energy is converted to the electrical energy. Or in case of a thermocouple, so have you seen the thermocouple in the geyser? So how the geyser works, or the fridge works, that in case of geyser, if you put on the switch, it will not like that the geyser will start heating for infinite amount of time. Otherwise, if you put on the switch of a geyser and come out of your room and it is there lit on for 12 hours or 24 hours, your geyser will get burst out, because lots of pressure will be generated, because your water will be converted to steam, and the steam will generate some pressure into your geyser, and your geyser get damaged. So it is not like that. What they do, that inside the geyser there is a thermocouple. So I think you know the basic principle of a thermocouple. Can you tell me the basic principle of a thermocouple? Any one of you? In physics class, you have gone through this. So what is the basic principle of thermocouple? Any one of you? Please don't keep yourself mum. You have to speak out. Whatever you know. And if you don't know, please tell me that I don't know. What is the basic principle of thermocouple? If you don't know, please write in the chat box that I don't know. Or please write 1. If you know it, please write 0 and tell me. Okay, you don't know. अरे physics में तो था thermocouple. Anyway, I'm showing you. Okay, here the pictures are not there. Anyway, so I am writing into the that case in the board. So in thermocouple, there will be 2 metal. I forgot the metal. One for metal is copper. Obviously, I forgot the what is the another metal. So one metal main job is to make you, when the heat generates, so what it will do, that it will start bending. So the metal starts bending, and there is a switch is there. Here is a switch is there. So due to the expansion, this metal will start bending. This metal will start bending, and at the time after bending, it will touch, whenever it will touch the switch, so immediately the sensor will come to know that the heat is at the optimum level. So immediately it will stop your geyser. Not only geyser, in case of broiler also, if the heat is generated up to a certain limit, that immediately the thermocouple starts bending, and after bending it will start, touch the switch, and immediately it will stop the geyser. Now when the geyser stops, now heating effect will also stop, and the temperature will cool down, and when the temperature will cool down, again the thermocouple will come to its original shape. The thermocouple will come to its original shape, and it will detach the switch, and immediately when the switch is being detached, then again the geyser or the boiler will start. So this is also one kind of actuator, isn't it? Now is this clear? Thermocouple concept? Not clear? Okay, okay, it's clear. Okay, fine. Okay, so thermocouple is also another kind of actuator. So because it is getting the electrical signals, heat signals from the system, and immediately it is changing, it is bending itself, and it is converting into the mechanical energy, and it is doing it. Okay. Now again, the electrical motor, or is it also transducer, which converts the electrical signal into a mechanical energy, like the solenoid that I have told. So that is also a kind of transducers also. Now I am telling that just now I have told that solenoid is an actuator. Now here I am telling this is a transducer. So what is the difference between them? Actually, an actuator is a kind of it's a subset of a transducer basically. An actuator is a device that actuates or moves something. An actuator uses the energy to provide a motion. So therefore, an actuator is a specific type of transducer. So transducer is in the generic sense, and your actuator is in a specific sense. That is a part of transducer is an actuator. Now is this clear to you? Sensor, actuator and transducer. If it is clear to you, please write 2. If it is not clear, then write 3. Then I will explain it again. Okay, Himjyoti, it is clear. Okay, Kaushik, it is clear. Pallav, it is not clear. Okay, fine. So, Pallav, I am telling you again. So, in case of sensors, we are sensing. Now, after sensing, what is the next job? My job is to, whatever be the sensor, sensing, whatever the things I am sensing, based on this, I have to make some mechanical action. Now, there is a controller which will take the sensing data, and after that, he will do the mechanical action through an actuator. It is not like that everywhere the mechanical action is required. Sometimes, suppose for a temperature monitoring sensor which is put in a patient, so that case I don't require any actuator. What it is doing, it is taking the sensing data, and after that it is sending to the database for analysis. But in case of the other sensing device, like the goggles that Himjyoti has made, not the goggles. Yes, the goggles itself also, it has an actuator. Now, Himjyoti, can you tell me what is the actuator in your smart goggles? What is the actuator over there? Himjyoti, what is the actuator over there? Okay, okay, yes. The buzzer in Himjyoti's goggles, there is a buzzer is there. Okay, so every most of, sorry, not every, most of the IoT devices we have an actuator is present. Now, what is the difference between the transducer and an actuator? The actuator is a kind of transducer. Both the transducer and actuator have the job is to convert one form of energy to another form, like electrical signals to mechanical signal, pressure signal to mechanical signal, or sound signal to mechanical signal. Now, out of this, the actuator specific job is to taking the electrical signal and create a motion or mechanical. Got it? In case of transducer, there are other signals will be converted to the form of other signal option. Means pressure, sound, that will be converted to mechanical signal, mechanical energy or any motion. But in case of actuator, it is taking only the electrical signal and converted it to a motion. So that is the difference between an actuator and a transducer. Now, is this clear to everybody? If it is still not clear, please write 3. Otherwise, I will move to the next topic. Okay. Now we have sensors in an IoT device. We have a controller in an IoT device. Now we don't require the transducer in an IoT device for the time being. We will consider only the actuator. Now in the exam also these questions will come. What is a transducer and what is the difference between transducer and actuators? Or you will be given some of the actuator and some of the mechanical devices. You have to tell them whether it is a transducer or an actuator, or you have to provide one sensor. Now you have to decide that these sensors will be connected with what type of actuator. Okay, now another important thing is that what is the resolution of a sensor? Now resolution of a sensor is that how much smallest change a sensor can detect in terms of quantity is measuring. Suppose some of the sensors are there, those who have worked with the sensor, some of the sensors are there, temperature sensor I'm telling you, they will give you a temperature range of 10 to 20 degree or 20 degree to 30 degree or 30 degree to 40 degree. Means if your temperature right now is in 15 degree, it will tell you that it is 10 degree because it is 10 to 20 degrees range. Now, if your temperature is in 27 degree, that time it will tell you 20 degree. Means that you have to make it plus minus 10 degree. Or if your temperature is 35 degree, it will tell you that 30 degree. Means that it's plus minus 10 degree I have to consider. Means its precision level is plus minus 10. Some of the sensors are there, they will give you the temperature range from 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35 like this. Now, if your temperature is 12, it will tell you 10 degree. If your temperature is 17, it will tell you 15 degree. If your temperature is 20, it will tell you 20 degree. Means that its precision or resolution level is plus minus 5. Or some of the sensors you will find out its precision level is plus minus 1. Means if it gives you 20 degree temperature, you will confirm that the temperature may vary from 19 degree to 21 degree. Now tell me which temperature sensor is better, precision level plus minus 1 or precision level plus minus 5 or precision level plus minus 10. You give me the answer in the chat box. Obviously plus minus 1. So it depends on more the resolution of a sensor, the more accurate its precision. That is why the few of the cheap soil moisture sensors are available in the market, which will give you in terms of 0 and 1. Means that if the moisture is there, that case it will give you 1. If the moisture is not there, it will give you 0. But from that, we cannot come to a conclusion that how much weight is the soil surface. And some of the moisture level sensors are there which will give you high precision value. Like it will tell you that the moisture level is 20%, moisture level is 30%, moisture level is 40% or 60%, like this. So which one is better? If the moisture level it is giving you at 20% or 30% or 40%, so that one is better to me or not? So at the time of purchasing a sensor, you have to check from the data sheet of the sensor regarding its precision level. Please check its precision level, how much precise or resolute data it is giving. Okay, I have only 10 minutes left. Okay, so I am going through the rest of the portion quickly. Now, there are various kinds of sensors available. So this is very important. First is the light sensor. I think you have seen that light sensor, that is called light dependent resistor. So what it is doing, so in the light sensor, have you seen? So there are few grids are available on the top. So in the top, some photovoltaic cells are available. Now, when the light illuminates onto the photovoltaic cell, immediately it will sense that the light has illuminated on it, and immediately it will activate it, and it will tell you, and it will also give you the result 0 and 1. It will not tell you that how much light intensity has incident on it, that is the 20% light or 30% light or 40% light. It is not going to tell you. It will just tell you that light has incident on that device only. So this kind of light dependent sensors, one of our students have used to create a smart street light. So what they have done that, and the street light to automate the street light switching option, they have used the light sensor. Means the daytime, when the light is there, it will give you the signal 1, and when it gets the signal 1, immediately through the relay switch, it will put off the light. And at the night time, or when the dusk is coming during the evening time, so when light goes off, it will give a signal 0, and immediately the light will go, or the street light will goes on. So based on the light sensor's value 1 or 0, the street light is put on or put off. So in this way, they are automatically controlling the street lights. Now there is another light sensors are there, photodiode. So I don't know and the exact precision level of this photodiode light sensor. It is also having a photovoltaic cell, which takes the light and converts that light energy to a it converts that light energy into the quantitative value. So whether the precision level is 0 or 1, or light intensity based, that I have to check this one. Next is the temperature sensor. So this is a temperature sensor thermistor, so which will give you at the precision level of ±1. So this temperature sensor is very much useful. So another temperature sensor is the thermocouple that already I have discussed. So it will detect the light intensity out of this. Have you seen that round thermocouple sensors? So whatever be the temperature it comes, so immediately it gets bent and sense it, and it gets bent and give the signals to a particular switch, so that the switch can work. Now, the force sensor. So, one of the example of this force sensor is the strain gauge. This strain gauge, have you seen that metal sheet? Now, in that metal sheet, if you put any force, immediately the metal sheet bends. And when the metal sheet bends, so it senses that how much forces has applied on that metal sheet. And based on the forces applied on that metal sheet, immediately it will give you one signal that how much pressure, atmospheric pressure, has been put on that metal sheet. And you can get the information that how much force has been given into the metal sheet. Now, can you tell me a very good application of this strain gauge, of this force sensor? Anybody? इस तरह का फोर्स सेंसर और स्ट्रेन गेज हम लोग कहाँ पे यूज कर सकते हैं? Shall I explain that strain gauge again, or any one of the sensor again, whatever I have discussed? Or am I a little bit fast? Shall I little bit slow down? रेलवे ट्रैक, अमृत कैसे रेलवे ट्रैक में यूज करोगे? किस काम में? यू अनम्यूट योरसेल्फ. अमृत तुम अनम्यूट करो अपने को एंड बोलो मुझे.
Sir, जब to measure the distance of a train traveling on a track, मतलब जो जैसे जो गेट होता है रेलवे गेट, तो मतलब ट्रेन कितना डिस्टेंस में है वो मतलब मालूम.
Exactly. Very good. Thank you, Amrit. So it's a very, Amrit, I am very happy that you have given this answer. In fact, in the railway track, the automatic signaling system, they use it when the train has come, that due to the pressure given on that strain gauge, immediately one signal comes into the nearest signaling station, signaling substation. And from that signaling substation, they stop the signal and stop the traffic also, so that nobody can pass by. And not only that, they also inform and the relay, because it's a route relay system, so they inform the next station and the previous station also that one train is coming through this track. So in this track, no other train should be given an option. This is one very good application of force sensor. Can you tell me in any other application where we can use this force sensor or strain gauge? Can you tell me any other application? Actually, I have 3 minutes left, so I will stop this and I will continue the rest of the sensor in the next class. Before that, I want to ask you, can you tell me any other application? Anybody? अगर नहीं आता तो बोलो, then I will tell you. At least I want some smart answer like Amrit. Okay, I'm telling you, in bridge, nowadays in bridge, they are using this strain gauge. Now, in the bridge also, some of the older bridge, which is 15 years old or 20 years old, they cannot take pressure more than a particular limit. So that is why in some of the bridges, they stopped the dumper, stop the passing of the dumper or the six-wheeler, 10-wheelers vehicles or something like that. They only, heavy vehicles, they only permit the light vehicles. Now sometimes the heavy vehicles don't obey the rules and they pass the bridge. So when they pass the bridge, immediately through strain gauge, there is a pressure will be generated and it will give a signal, and that signal will come to the PW offices, and immediately they can check through the camera that which vehicle has passed through this bridge, passing which is exceeding the required force limit, and immediately they take the action. In the dams, okay, Saurabh, tell me how in the dams, so they take this kind of strain gauge. What is the application in dams? Saurabh, please unmute yourself.
हेलो सर।
हेलो, बोलो सौरभ।
हेलो।
यस, आई
सर
कैन
पहले
हियर।
हम लोग का जो पानी जो आता है ना सर, जब पानी कहीं से आ रहा है, अगर किसी जगह ज्यादा हो जाता है पानी, इस समटाइम अगर कहीं पर जैसे गिरजा ने बोला कि फ्लड जब हो जाता है ज्यादा, किसी जगह मतलब ज्यादा पानी जमा हो रहा है, वहां से हम लोग को बाहर निकालना है। जब जब प्रेशर प्रेशर तो बन जाता है ना, उधर प्रेशर बनने के बाद उस टाइम को
इसमें यूज करना थोड़ा मुश्किल है।
हेलो
फ्लड का जो प्रेशर है, हाँ सौरभ, यू हैव आंसर्ड, ट्राई टू आंसर इट, बट द प्रॉब्लम इज दैट फ्लड का जो प्रेशर है, दैट प्रेशर
हाँ हाँ
not in a specific position. Like in the dumper case, it will come into a specific position, right? From that, a huge pressure will be
या
generated in valve. But in case of flood management, the pressure actually spread across the entire space, so it doesn't work like that. So in case of flood management, what they do that they use position sensor. I will tell you how the position sensor help
ओके
you
ओके
flood management. Okay. Okay, so thank
ओके
you.
सर।
It's a very interactive session. Everybody tries to answer it. So I want this kind of interaction from you people. Thank you once again. So hope to meet you in the next class. So right now